Welcome to Lesson Up, math tips, tricks, and other ideas. To help continue expanding this site, don't forget to subscribe and like. Have you ever played the board game Trouble? This game was first introduced by Hasbro in 1965 and is still a top seller today. Its unique gimmick features a Pop-O-Matic die roller. According to the rules of the game, I had a group of students who wondered what is the probability that after one full round, that's 4 rolls total, a player has entered the game. Now, Trouble is a 4-player game in which each player has 4 colored pegs stationed in a home area. Players aim to be the first player to move their 4 pegs from their home area all the way around the game board and into their finish zone. The game relies almost entirely on the roll, or in this case the pop, of a 6-sided die numbered 1 through 6. However, in order for a player to enter one of their pegs into the game, they must either roll a 6 on their turn or have another player roll a 1 during theirs. If you'd like to try this problem on your own, you should pause this video now. Now, students instinctively understand that there is a 1 out of 6 chance of rolling a 6 or rolling a 1 or any other number for that matter. Their immediate response is to determine what is the probability of entering the game on any particular player's turn. There is a 1 out of 6 chance a player will roll a 6 on their turn, or there is a 5 out of 6 chance they don't roll a 6 and a 1 out of 6 chance the next player rolls a 1. Of course, this pattern continues for all 4 players. Students correctly then sum up these results for their probability solution. Now, without a doubt, it's good to observe students work their way through a problem like this. However, I let them know that there is a more direct and simpler approach. As we place this game's scenario into context, it implies that something else is occurring, though not specifically stated. In other words, for a player to enter the game, that means at least one of them has to roll a successful number. When I address this to the students, they recognize that the phrase "at least" implies the complement. So rather than determine each turn's outcome in which one of them has to be successful, they determine the complement in which none of the turns are successful. Utilizing the complement, they immediately determine the probability. Now, it's important for students to understand that not all scenarios will explicitly state exactly how to proceed. More nuanced and implicit circumstances are usually encountered. So consider this scenario. Suppose a player has 2 of their pegs in the finish zone and the remaining pegs are positioned as shown. If a player has to roll the exact number to land in an empty spot, what is the probability they will advance only one of the pegs into the finish zone on their next 2 rolls? Again, if you'd like to try this problem on your own, pause this video now. A student's instinct is to concentrate on counting all possibilities moving individual pegs. The trouble is this practice can quickly get awkward and you can easily lose track of your progress. The focus should be on the number of outcomes. When you think about it, there are only 3 possible outcomes for this scenario. After 2 rolls of the die, either both pegs advance into the finish zone, neither peg advances into the finish zone, or only one peg advances into the finish zone, which is what we want to determine. On the first roll, either a roll of 2, 3, 4, or 5 will result in one of the pegs advancing into the finish zone. Thus, there is a 4 out of 6, or 2/3 probability of advancing a peg on the first roll, and with one remaining open spot, a 1 out of 6 probability of advancing the remaining peg on the second roll. So there's a 1 out of 9 probability of getting both pegs into the finish zone on the next 2 rolls. Consequently, for neither peg to advance into the finish zone, then a roll of 1 or 6 must occur on both rolls. Thus, there is a 2 out of 6 or 1/3 probability of not advancing a peg on the first roll and a 1/3 probability of not advancing a peg on the second roll. So again, there is a 1 out of 9 probability of getting neither of the pegs into the finish zone. Now, since there's only one other possible outcome for this scenario, that is only one peg advances, then we could introduce the complement. Therefore, we can subtract these results from 1, which leaves 7 out of 9, or 77.78% probability of advancing only one peg on the next 2 rolls. Please don't forget to subscribe and like, and we'll see you next time.